Welcome back to my series on ES6. Today we're going to cover new methods and miscellaneous syntax added in ES6, but we're not going to cover quite all of it. The current order of ES6 topics are as follows. Today we're on number 3. I have all 8 written and just need to record them. So the first object we're going to introduce is the set. A set is a collection that contains unique elements. Uniqueness is determined by reference for objects and values for primitives. Therefore, you can't add the same string, integer, etc. So 1 and 1 added to a set will only have one instance of the number 1. 2 instances of an object cannot be added, but if you have 2 separate objects with the same exact properties, that can be added. Here you see me declaring a new set containing the elements 1, 4, 5, 3, and 1. And as you can see, the output for each of those is 1, 4, 5, and 3, dropping the last one. Methods available on the set object are as follows. We have add, which is pretty self-explanatory. It adds to the set, and it does not error if you attempt to add a duplicate. Clear empties the set, giving it an empty value. Delete removes a given value or reference, so if you have an object, you have to actually remove the reference, not a duplicate. For each iterates over the set, as you saw in the previous example, and it performs a callback for each of the element within the set. We also have has, which determines whether or not a set contains a reference or value. The full API is available on the link in the slide, so if you want to view that, go ahead and load up the slide and click on the API link. Next we have maps. If you're familiar with JavaScript, you realize that a map is a set of key values, but so are JavaScript objects, right? However, maps are better for mapping for these following reasons. Maps do not have a set of properties when you create a new instance. Objects do because they are a prototypical object. So if you were to instantiate a new object and output the property toString on it, you'll see that it has a function already declared on that object. However, you actually have to, if you attempt to retrieve toString from a map, you'll get undefined because that does not exist within the map. However, after you set it, it does become available. Keys can be anything you want inside a map. Not a number? Yes. 1? Yes. Do I have to use strings to represent any of those values? No. You do, however, have to do that in a JavaScript object. Maps also have the ability to tell you how many elements have been inserted into the map. The methods on a map are as follows. It contains has for each, delete, and clear, and those follow the same behavior as set. And we also have the term set, which is used to add to the map. It takes in a key and a value pair and pushes the pair onto the map. It is then accessible via the get function using that key that you use to register it in the map. The full API is available on this link. Next, we're going to talk about the array methods. There are several new array methods added in ES6, including find. The basic syntax of find is to call .find on an array with a given callback. The callback determines the criteria to match, meaning you can analyze properties or the given value inside the array to determine whether or not it has been found. So here you can see I have 2 objects with properties A42 and A55. I log the item that matches 42, the value 42 on the property A. It outputs the first element of the array. If there are more than one element that match in a given collection, it will return the first instance of the match. Think of this like performing an if matches break in a for loop. Next, we'll talk about filter. Filter is similar to how find works. It takes the callback to determine whether or not it matches a criteria, but instead of returning the first instance, it returns the collection of all matching elements. Here I have 2, 4, 5, and 6, and what I'm filtering on is even numbers. So you can see when I perform the filter on the array, it outputs 2, 4, and 6. Next, we have Array.from. It converts an iterable object, such as the arguments array or a node list, which are array-like but not quite arrays, into an actual array prototypical object. This is useful for accessing array prototype methods on a collection that was not previously an array type. So for instance, if I grab all the divs on the web page using document.querySelectorAll, I'm going to get a node list back. But if I want to perform map, it won't work on that node list because map is not a function defined on the node list prototype. However, if I use Array.from, which is a prototypical function of array, it will actually convert that into the array, and then I can then perform the map on that same collection. Next, we're going to cover Object.assign. Object.assign is useful to assign multiple properties onto an object in an easier to read fashion than declaring them one by one. The basic concept is that it merges the rightmost objects onto their left object, joining properties where there's no overlap and overriding where there is an overlap. As you can see in the function called down below, I have Object.assign with the first parameter being a new object with the property C equal to 42. I then pass 2copy B and 2copy A. 2copy A gets merged onto its left object, 2copy B. So the properties of 2copy B are now assigned onto 2copy A. So the property B is now available to that object, but the value of A is actually 42 since A came from the rightmost object. If you then merge that down onto the first parameter containing C42, you'll have all three properties. Okay, but why is this easier to read? If you're familiar with setting several things on an instance of an object, you'll know that you use this dot property name is equal to value. So being able to do this all in one function call becomes really simple. If you remember the simplified object declaration from previous videos, you can see that I can drop the need for duplicating the key value pair, and I can even merge it down into A, B, C, and D and assign that onto the this reference. This makes that much easier to access all four of those parameters from the instance of the object. Next, we're going to get into some string methods. We're going to start with startsWith. It's pretty self-explanatory. It determines whether or not a string starts with a string to match. The second parameter can be used to give it an index to start searching for within the string. It defaults this to 0. Here are a few examples to show how you would use this. The first is pretty self-explanatory. It starts with E, true. Next, Evan does not start with B, so it's false. But if we start at the first character in the string, remember this is 0 based, we're going to see that E is not being matched because the first letter in the string is actually V. Next, we have endsWith. This is the same as startsWith, but in reverse. Next, we have includes, which is very similar to both, but it applies to the full string. So why are these functions handy? It replaces the need to use index of statements, such as the following. Evan.index of E is equal to 0, is how you would do startsWith. To do endsWith, you have to check from the back and determine whether or not that character is at the last index character of the string. And how to check includes is to basically say if it's not equal to -1. So this is nice to have because you don't have to remember what is returned when a string's not found, which is -1, or compare against the length of the string and have to remember to count in for the difference between length and 0-based index. Next, we will cover the things that I left off and will not go into detail about. The reason for this is I don't find a lot of these useful or haven't used them in my day-to-day. If you're curious about them, feel free to check them out on Google. So iterators and generators are ways of creating a custom iterable object. I didn't cover these because I haven't found a use for them yet. The common scenario that they use as an example is a Fibonacci sequence, and to be honest, I don't use that in my day-to-day. Next, we'll cover Unicode, binary, and octal. These are all literals that support full Unicode, binary, and octal in source code. So if you wanted to use a binary notation, if you wanted to use octals or Unicode characters such as like Chinese characters or other forms of accented characters that you don't have in your standard ASCII availability, you can go ahead and do that now in ES6 and it'll convert that for you. I don't cover it because I'm an English only speaker and don't have to deal with this. I have never had a need for binary or octals, but if you do something with like graphics in JavaScript, that might be more likely. Next, there's proxies. To be honest, I really don't understand these or their use case, so you can check out the full API at the link provided. Next, there's symbols. These are a new primitive type. They're an interchangeable way of assigning properties to an object, and you can use a symbol as you can string to access properties from an object. Again, I don't cover this because I don't use them in my day-to-day. Next, we have tail calls. These have to do with recursive function calls and aiding to not overflow the stack. So basically helping with managing that stack that gets generated when performing recursive function calls. And again, I don't use these because I fear recursive calls. I'm terrible at determining the base case and breaking the loop. Plus, in my day-to-day, I really don't encounter recursive functions all that often, so I'm no expert in them. So that was miscellaneous syntax added to ES6. I'm about to record the next video, so hopefully I can get that done. I hope that you've enjoyed this and look forward to teaching you the next one. As always, you can contact me on LinkedIn or Twitter, comment down below, all the usual YouTube stuff.